Hello everyone. In this video, we are going to discuss about this topic Ohm's law from the chapter 3 current electricity of class 12 physics. So here we are considering a conductor or a material of length L through which some current I passes. And let A be the area of cross section of this conductor and V be the potential difference across it. Okay, then from Ohm's law, we know that this V potential difference across the 2 points of the conductor, across the two ends of the conductor, that is proportional to the current through it. Okay, and we can write it as V is equal to some R into I, where this R is known as the resistance of the conductor. Okay, we know that the SI unit of resistance is what? SI unit of resistance is ohm, which is represented by this letter. And you see, from this expression, we can write R is equal to V by I. Okay, so we are getting R is equal to V by I from this expression. Now, let us just consider, so this is a conductor, or we can say that it is a conducting slab. So now let us just consider two such identical conducting slabs. Okay, of the same length, same area of cross section, everything same. Okay, now when we connect these two identical slabs like this, that is end-to-end connection, that is like a series combination, then what happens? You see the potential difference across the first slab is V, potential difference across the second conducting slab is V, length of the first conducting slab is L, length of the second conducting slab is L. I is the current flowing through the first conducting slab, the same current flows through the second one as well. Okay, an area of cross section of each conductor is A. Now, if we consider the combination of these two identical conducting slabs connected like end to end, then what happens? So, in this case, the potential difference across the combination, that will be equal to what? The sum of potential difference across the two individual slabs, that is V plus V, which is equal to 2V. Now, what about the resistance of this combination? I am taking the resistance of the combination as RC. When there was only one conducting slab, its resistance R was equal to V by I. Now we have two identical conducting slabs connected like this end to end. So the resistance of their combination RC will be equal to what? Potential difference across it, which is 2V, divided by the current, which is I. Okay, see what is V by I? It is R, so we can write it as 2R. That is, when length of the conductor was L, its resistance was R. But when we doubled, you see the total length of this combination is L plus L, which is 2L. So when length became 2L, its resistance became 2R. That is, doubling the length of the conductor, it doubles the resistance. So length of and resistance are directly proportional. That is, resistance of a conductor, it is directly proportional to the length of the conductor. Now, let us divide this conducting slab into two by cutting it lengthwise, horizontally. So, we get two identical slabs of length L. Okay, this top one will be having the length L and bottom one also will be having the length L. And each having the cross-sectional area. What happens to the cross-sectional area? Here it becomes A by 2 and the bottom one also it will be A by 2. A is the cross-section, area of cross-section of the conducting slab. So here it becomes A by 2, A by 2. You see the current through the entire slab when we consider this combination like this. That is, one conducting slab is kept here, another one conducting slab is kept here like a parallel combination. So current through the entire slab is I by 2 plus I by 2, which is I. Current through each of the two half slabs, that is I by 2. Potential difference across each slab will be V. That will be the potential difference across the all slab. So, if you take the resistance of the first slab, R1, that will be equal to what? Potential difference across the first slab, which is V, divided by current through the first slab, which is I by 2. Multiplication with reciprocal, this will give you 2 into V by I. That is 2 into R. Okay, similarly, the resistance of the second slab, R2, that also will be equal to potential difference across it, V, because it is like a parallel combination, divided by current through it is I by 2. So, this also becomes 2 into V by I, which is 2R. That is, here you see, in this case, the area of cross section became A by 2. Okay. And what happens to the resistance? Resistance became 2R. Okay, that is, having the area of cross section of a conductor, it doubles the resistance. That is, when area of cross section has decreased, resistance has increased. See, resistance has increased. So we can write resistance, it is inversely proportional to the area of cross section. That is, R is proportional to 1 by A. Now, by combining these two, we can write R is proportional to L and it is proportional to 1 by A, so A is in the denominator. Now, when we replace this proportionality sign with an equal sign, we will write one proportionality constant here, L by A. This proportionality constant rho, this proportionality constant is rho, which is actually the resistivity of the material. See, resistivity depends on the material as well as the temperature of the material, that conductor. It does not depend on the dimensions, that is the length and area of cross sections of the conductor. Now you see, from Ohm's law, we have V is equal to R into I. This can be written as, what is this R? Rho L divided by A into I. See, this I divided by A, current per unit area. This current per unit area, this is known as current density J. J is the current density, current per unit area. So this equation becomes what? V is equal to J into rho into L, where J is the current density. Now you see, we got an expression for V as J rho L. Let it be there. If E is the magnitude of the uniform electric field in the conductor of length L, then the potential difference across the conductor, that can be expressed as electric field times the length of the conductor. Okay, now by comparing these two equations, V equals E into L, V equals J rho L. That is, we can write EL is equal to J rho L. Okay, see, this L can be cancelled, so that we get E is equal to J into rho. Okay, in vector form we can write it as vector E is equal to vector J into rho, where vector J, that is the current density, that is current through unit area normal to the current, and it is also directed along the electric field, vector E. Now consider this equation, vector E is equal to vector J into rho. If we take this rho to this side, that goes to the denominator. So we can write vector J is equal to 1 by rho into vector E. This is 1 by resistivity. 1 by resistivity, this is actually known as conductivity. 1 by resistivity, that is actually the conductivity sigma. So we can write it as vector J is equal to sigma into vector E. See, this equation, it is an equivalent form of Ohm's law, or it is a vector form of Ohm's law. So in this video, we have discussed about Ohm's law from the chapter 3 current electricity of class 12 physics. I hope it is clear to you. Thank you.